So good evening. We may as well get started. It's about 5:30 now. Welcome to the for the next Exploring Ethics program. One of the things I want to check at the very beginning is how many of you are here for the first time tonight. Okay, so we are still majority are return customers, meaning that we must be doing something right. My name is Mike Kalichman. I'm the a co-director for the Center for Ethics in Science and Technology. Those of you who are new, we run these programs once each month with the Fleet Center. Provide different positions just in case. And the microphone may go in and out. We'll see how that works. For tonight's program, we have a moderator that has spoken here before, and the punishment he gets for having done so well as a speaker is that he will now be tonight's moderator, and that's Stanley Malloy from San Diego State University. Stan is a microbiologist and actually suggested tonight's topic and helped arrange plans for tonight's program on data. It was something of particular interest to him, and I'm going to let Stan explain what he's thinking of for tonight's program and how it will work, and he'll introduce the speakers as they come up. Stan.
So I'm going to give a very short introduction, and then I'm going to turn it over to the first speaker tonight. So the basic issue is that most scientific research is funded either by the federal government or by private industry. And if research is funded by the federal government, and that research is something that could influence your own health or your decision about an important public policy, since you were a taxpayer that paid for that research, shouldn't you have a right to access that data? It seems obvious, right? Now, there are a few problems with that concept, and the problems go from things that affect individuals to larger types of issues. One of the problems is that if too much data gets out in the public domain, sometimes there are issues that affect privacy of an individual. Right? So one example of this is Jim Watson, very famous scientist, got the Nobel Prize, the co-discoverer of the structure of DNA. He had his genome sequenced and published online, but he was very concerned about one particular gene, the ApoE gene. And he was concerned because if you know the allele of the ApoE gene, you can make a very strong prediction about whether or not somebody will develop Alzheimer's disease. Okay? He didn't want the public to know this information. So they blocked out that little piece of information from his record. But scientists figured that if you look at all of these other changes in his genome, you can make a very strong guess about what his ApoE gene is like. Okay? So sometimes you can't make data invisible when it's available online, and that data will infect health records of Jim Watson, but also it will influence all of his relatives and people that he knows. Okay? So one problem with too much release of public data is that it can affect an individual's privacy. A second problem is that scientists get funds to do what they do by writing grants and working very, very hard to get data together. And if they get all that data together and then they put it in some public forum online, some other scientists might come along and take their data and use it before they've had a chance to, right? Scoop them. Right? Now, this is a big problem because the way scientists get the funds to keep doing research is by publishing their data. So if they get scooped, they may not be able to continue. So it can influence the ability of scientists to continue their research. A third very big thing is that release of data too fast can influence whether or not you can patent information. And the ability to patent influences whether that scientific information can be used to develop a new therapy or a new drug. The estimate nowadays is it costs about $1 billion to take a new idea for a drug and develop a drug from it. $1 billion. So if a company doesn't have the promise of a patent, they may not touch something that could potentially help a lot of people's lives. There are some other issues that I think Phil Bourne will touch on in just a little bit, but in the same, they all fall into this idea of where there's some problems with too early release of too much data. So the question is, where is the balance? How do we figure this out? Do people deserve to get the data no matter what? Can we provide protections against these other types of things? Where does the deciding line fall in terms of access of us as people to scientific data that could affect our own lives online? So we're going to have a speaker today, Phil Bourne from UCSD. Phil is a professor in the Department of Pharmacology at UCSD. He is the Associate Director of the Protein Data Bank. This is one public, accessible, large information database. He's the past president of the American Medical Informatics Association, and very importantly, he's the founding editor-in-chief of an open access journal called PLOS Computational Biology. So this is a journal that's built on the idea of releasing information freely to the public. Phil's going to begin by giving a short talk and introduction on the subject, and following that, Phil and our other panelist, Assis Bakswala, will answer questions from the audience. So let me briefly introduce Assis before we move to that stage. Assis is the head of clinical informatics at UCSD Health Sciences. He is involved in the clinical data warehouse for biomedical research, implementing clinical trial management systems, and integrating clinical decision support technologies into healthcare delivery. So he is very closely involved with access of data that influences people's personal health records. So with that, I'm going to turn this over to Phil. Give a short talk.
Here we go. The usual stalling start. Thanks very much for that introduction, Stan. It's very nice of you. It is a very interesting question. And I have to say that I wasn't necessarily sure of the answer myself. And I actually went to the UCSD website, which is my institution, to ask to see whether I could find out who owns the data. I was assuming because I was a university employee, the university owns the data that I produce while I'm there. I actually couldn't find anything that was really substantive that described the answer to that question. So I then contacted our head of the tech transfer office at UCSD, and after some delay, I actually got an article that was dated 1958, which is about the time the university was founded. I think it was really a UC-wide statement, and it wasn't directed explicitly at UCSD. So I think this is a question that's really on people's minds these days by virtue of the amount of data and the complexity of data that we now have, but we don't necessarily have good answers to it. And what I was hoping we'd do today is to have a nice discussion about that. And because I have to say I'm a very open data zealot, needless to say, if you go to this website at the bottom, the slide, you can actually, that's my lab website, and you can find these slides should you actually care about them. So I'm here to have a dialogue, not a monologue. So I'm going to make this rather brief so we can get into the discussion part. Who recognizes this? Anyone? Oh, I'm a little disappointed. I'm gauging the audience. This is from Monty Python. And it's actually a scene from The Meaning of Life, where he's giving out conversation cards to a couple having their dinner. So if they have nothing to say to each other, he gives them a card on philosophers, and then they start having a conversation around philosophers. So what I'm giving for you tonight is, or giving to you this evening, I hope, is a few of these conversation cards. And from that point we can move forward and have a nice parlay. So let's get the dialogue going. And I want to do it around a real life scenario to sort of highlight the issues that are associated with this question of who owns the data. So this is actually, and there's someone in the audience who knows this, but this is actually a real life situation for us. If you have a friend or a loved one who is diagnosed, in this case, let's just say with a solid tumor, and it hasn't, the kinds of treatments, radiotherapy, chemical treatments, and drugs, anti-cancer drugs, have not been very effective. So it's suggested by a physician that this person should actually try a new antibody treatment. And so if you are that person or you're associated with that person, what would be the first thing that you would do to find out more about this treatment? What would you do? Google. Sorry? PubMed. Oh, that's very sophisticated already. We'll get to that in a second. So PubMed, Google. Anything else? No, that's actually a good point. But in terms of information sources, well, I'm interested you didn't say that. But I would probably, the first question you might ask if as a layperson is what is an antibody? And if I wanted to answer that question, I might actually go to Wikipedia. And that would be, Wikipedia has a pretty comprehensive description there. There's actually the structure of antibodies and so forth. So I think the first thing to know is we are a generation with the world's knowledge at our fingertips. And this has really changed everything. I mean, I'm absolutely convinced, and I say this all the time, that the students that are just getting smarter and smarter. And I think part of it has to do is that they basically had all this information accessible to them. But very rarely do we actually think about that information in the context of who owns it and other aspects associated with its authenticity and so on, which we'll get to in a minute. So the question then is who owns it? And then how authoritative is it? Who added it? Where are those people from? Was it peer reviewed? And then in this case, do people here know how Wikipedia works? Okay, so basically, you go and you can create a Wikipedia, you can sign on, create a Wikipedia page, add some data, some information, and then other people are free to come in and make changes to that. And so it's a notion of crowdsourcing. So ultimately, the viewpoint that appears on that page about this antibody is essentially a collective wisdom of crowds. Okay? Does anybody know who owns that information? No, no. Well, if you actually dig down, and there's a tiny little about button at the bottom of the Wikipedia page, you can pull up this thing, and it's what's called a Creative Commons license. And I won't go in, and this is actually very nice because below this is like pages and pages of legalese, okay? This is the layperson's view or it's for the layperson to interpret, and I can understand most of it. The essence of it is that whoever posts it owns the information. If you go in there and you use it for another purpose or you change it, you need to actually attribute the original author. And whatever you produce from it actually has the same licensing arrangement, the same license, if you like, as the original material. I'm simplifying it a bit. But you get the idea. So it's basically within the public domain, but whoever created it needs to be attributed. So this is one example of who owns the data. So let's take the obvious next step. So this is the first conversation card is this kind of licensing thing. We could have a discussion around that and get into a lot more detail about that should you be interested in that. So let's take the obvious next step. I now want to know, well, I put in cancer and antibody and I want to see in Google, as you suggested, what would actually happen. Well, of course, what happens is that there are, you perhaps can't read it, 8.8 million pages associated with this topic. Now, it's true that the page ranking algorithm for Google is working for us, but the point is we are absolutely awash in scientific data. Okay? So this is going to be another conversation card, okay? I'll come back to this. And what I wanted to do is to show you, I had to show you one slide from my own work, just to illustrate this fact, okay? And why we're actually in this kind of situation. So each one of these things is a protein structure, and you have about 20 or 30,000 proteins that we're all composed of, and they have three-dimensional structures, and those structures are very important for things like drug discovery. Now, it turns out this is maintained in a public resource that I'm involved with, so you could go there. If you cared about this, you could go there and play with these molecules on the screen, okay? So a couple of things to note here. It's gone off the bottom of the screen, but it doesn't matter. That's the timeline, okay? It goes back to the early 70s. So this, up here is the growth rate. So you could see there's been this very large growth, okay, of data. Now, this is just mirrored in almost any imaginable situation. I'll give you some other examples in a second. The other thing about it is the complexity of that data. By virtue of all of these structures here, are actually drawn to scale. So we started off with a very simple structure, and we've got to these very complicated ones. But what's important is when the first person, there's several Nobel Prizes down here, okay? When that first work was done, it was a life's work to get one of those little blobs on that screen. Now, to get the average type of structure takes a matter of weeks. Now that, of course, has come about by improvements in technologies and automation, our understanding. What it has the effect of is to change how people perceive the value of data. When you had your whole life tied up in this one thing, you're a lot more protective than something that's only, that you're going to create again or something similar to it in a couple of weeks' time. So that sort of feeds into this notion of the value of data. So what are some of the other implications? Well, let me give you some of the other data. So here's the Hadron Collider, which is now sort of working. And that is generating petabytes, huge, millions and millions of bytes of information. Here's the Digital Sky Project, which is mapping this. I'm just giving you a couple of examples here, okay? That's mapping parts of the heavens and star positions and so forth. Then, of course, there's the Human Genome, which was completed in 2000. But what people don't particularly pay attention to is the fact that there are now many hundreds of genomes of many different organisms, huge amounts of data, and now we're into so-called GWAS studies, where we're actually looking at differences between individuals. And so, we're estimating now that in probably 5-10 years or so, everyone will have their genome done at birth. It will cost $50, okay? So this is a huge amount of information. Again, there's lots of issues associated with the security of that information, which we'll get to in a second. So, with all this information, as I've said already, it's less perceived value. I think what's also important is we have a lot of this information is digital. Now, in one sense, that doesn't really make much difference, except it's a really convenient factor. How easy it is for you to send a photograph to all your friends, okay? It takes that amount of time. It used to be to shift data around. When I was first working on these protein structures, we used to send these huge reel-to-reel tapes like that, and you can probably tell by my accent I was actually living in Australia, and I would wait for these tapes, 3 months for these tapes to come by sea mail. That amount of data comes to me now in a fraction of a second. That's a big difference. So these are some of the big changes. It then leads to this whole notion of e-science, where almost everything associated with science in some ways linked to the computer and information exchange. But then I think the incentives to share are greater by virtue of, in part, because of the simplicity, but I think there are other reasons too. I think scientists are changing, okay? For the better, I would say. So in my generation, we were seen and not heard, but now we're heard and not seen. And in some cases, of course, with YouTube and other types of technologies, we're seen as well. So there's a big change there, okay? I mentioned about the world's knowledge at the fingertips. And we are a generation of scientists that communicate very broadly in many different ways, including forums like this, okay? So these are 4 students from my lab, okay? They have a very different attitude to the attitude I had when I was their age. And, there are reasons for this. Each one of those I snuck up when I thought they were working very hard at the computer, and they were all watching YouTube. But notwithstanding, they are definitely more open. I actually heard a talk from a young assistant professor, a really sharp young person last week, and during that talk he said, I will email to any one of you in the audience the paper that I've submitted to a journal. It's not yet accepted, but I'm quite happy to share it with you. That would have not happened in my era. So I think there's, and you can argue, and maybe we will, I hope, that the idea of this, that maybe this comes from this idea of social networking and open communications that people seem to have with each other. Maybe it doesn't, maybe it comes from something else, but it's an observation. But at the same time, and Stan alluded to this, is that there's this balance we have as scientists between our natural desire, perhaps, to disseminate information and the need for reward. It's partly personal reward, but it's also partly the fact that, tenure comes from actually publishing really good papers. So everybody, in the academic environment at least, wants to get that kind of reward. So to do that, that tends to make you a little guarded because you don't want to be scooped by someone else who's using your data. So, but at the same time, part of you wants to disseminate it. So you're always in this kind of balance. Fortunately, when you get to my age, you don't care anymore. You've got tenure, and I just throw things out the door whenever they come along. So the question is, it's going back to this idea of the antibody and whether this is a good treatment for this person. The question then arises, you had these 8 million examples, but Google has told you that this piece of information is number one. Would you entrust your friend's life to a Google page ranking algorithm? Okay, well, we could discuss that. But I have to say that the page ranking algorithm is not quite public, but it's almost public. So kudos to those, to Sergey Brin and I've forgotten his other name now. So the answer no coming from the audience is clear that authenticity and quality are paramount. That's how I interpret that no. If you're actually trying to say something else, we'll get to that in a minute. So, that's clear. But peer review helps this, okay? So if you're dealing with a scientific literature, presumably the peer review process that things have gone through actually help the process. So the idea of going to PubMed, which is an aggregation of all biomedical literature that you would actually look at that's been peer reviewed for the most part, that would appear to be a good source. And so you might pick those appropriate elements out of your Google page list that represent things that were in PubMed. Indeed, some of them are. So that's, that sort of helps you with the quality. But at the same time, the system is under pressure due to the amount of material we are currently producing. Since I've been talking here, probably 100 papers have been, in the biomedical sciences, have been indexed by PubMed. We're generating 1.2 million scientific papers in the biomedical sciences per year. When one of my students comes in with their very first paper and they're so proud, I look at their face and there's just no way I could tell them. In the moment you walked in my office, another 3 papers have already been published. It's just, so the system, in my personal opinion, is tottering on the brink of collapse by virtue of the fact we're producing so much stuff, no one has time to review it anymore. So I think the quality of review could indeed be, or I believe is declining. So that might impact in some ways what I set up here about authenticity and quality. Again, this is potentially a conversation card, should you care. So, and Stan made this point, but assuming that we believe the quality of this material that gets published, there's a problem that Stan alluded to. And that problem is that these kinds of leading-edge bioscience journals, Science and Nature, they contain other kinds of science too, of course, essentially you have to buy. Even though a lot of the research that's in them was actually paid for by your dollars, you cannot read that research. You can go to PubMed and you can read an abstract, which is about that much of the paper. But if that tweaks your interest, you have to pay $30 or thereabout for one of these, okay? There's been a big move afoot, of which I'm actually part, which is called the Open Access Movement, where there's been a very conscious effort to actually make the scientific literature free. And I'm involved, here's one of those journals, it's called PLOS Medicine, but there's a series of PLOS journals. PLOS stands for the Public Library of Science. It was founded by Howard Varmus, who's a Nobel laureate and former head of the NIH, and 2 other scientists in Northern California to actually try and make as much of the scientific literature as free as possible. Now, there are other implications to this, apart from being free to read. It's all online and it's all in an electronic form that can actually be massaged by computers, so information can be got out of it. If you've got 1.2 million papers a year, it's really good to have some mechanism to actually do some filtering, if it's done carefully. Again, another conversation card. So is this access necessarily a good thing? And again, Stan alluded to this, but let me go into a little more detail. So science is a process, okay? And so effective use of data, any step requires that the process be understood. So you can go in there and you can use some data, and it may actually be that this is negative data. It may be actually a negative result, and you may not appreciate that by just looking at the data, assuming you can interpret it, okay? So that's not a bad thing from the point of view of science, because quite often we move forward by knowing what's wrong, not what's right. So, but if you actually take one little slice of that information and you look at it, it could be, you could misinterpret it. So there's dangers in all of this. And I think that's something we should probably, hopefully, discuss. We can also, there's access also with respect to particularly patient data, for example, your own patient data. So one of the issues is that the idea that if you're smart enough, you even though due to HIPAA regulations and other things, the patient is actually secure in principle, if some of that information gets out, it may be possible to actually reconstruct and find out who that person is. I mean, that's generally difficult, but it's not, it's not something that under some circumstances might not be possible. So there's always this issue of misuse. Okay, we know all about climate change and the potential misinterpretation and misuse of data there. So this is something perhaps we can come back to and discuss. But at the same time, so here's keeping data secure, but at the same time, it's going to, we're now in an era where we're going to have a much broader electronic patient record. So your information is going to be in electronic form. So the onus on keeping it secure is all the more paramount. But at the same time, there are websites like Patients Like Me where people actually purposely make their own health record available and discuss it with other people. So it really depends on who you are and your point of view. Okay, Bourne, so here, did I really answer the question? Who does not own the data? And let me just then basically try and answer the question and then finish up. So in most cases, if you're in industry, then it's very clear cut. In many cases, you cannot I could not make this presentation without having approved by an office within my organization to make sure that I was not in any way giving anything away. And that's also true often in national labs where there's issues of national security. In a private or public university, and let's just say public university, no one actually monitors that. I am really left, even though the material, my data and these slides and everything else, because I sat in my office this afternoon, I should have said I made them weeks ago and I've been thinking about them ever since. but that was done in my university office. The university owns these slides. Now, no one has ever, in the university, has ever enforced that kind of situation, but that's the implicit, as I understand it, the implicit situation. Then, of course, you have the granting agencies. So if I have a grant from the federal government, it's typically, because they award that grant to the university, the ownership of whatever I do falls to the university. It can be given to the university back to the federal agency. And in some cases, it's actually owned. The transfer can be made to the individual themselves. So this is sort of like healthcare reform. Who owns the data is rather a complex question. And there are many, many different situations. And we can certainly get into a few of those. Okay, so here's the key points here are your conversation cards, okay? So there's issues associated, when you think about who owns the data, there's issues that the answer to that question is affected by the quantity of the data, the quality of that data, the scientist's attitude towards that data, the natural accessibility of that data, and security and misuse. So with that note, and because none of you are really into Monty Python, I won't even try and begin to describe what's going on any further than I did before. But here's just an example of the situation and why this is important to us as people in the public as well as scientists. This was actually taken from today's New York Times, and it's essentially scientists now pushing back, trying to explain to the public the situation associated with the data that was actually obtained on climate change. So there's this, one argument could be that in fact this data was misinterpreted by the fact it was taken out of context. On the other hand, maybe there's something actually in it. I haven't actually personally. Has anyone actually looked at any of this data that's associated with this whole issue? You know the issue, right? It was stolen from computers in the UK. So it's hard to know the true answers to these questions without actually having access to the data. But it's an example of misuse. So I think it's something we need to consider. So on that note, I'll stop, and hopefully we can discuss these and anything else that you have in mind. Thank you.
Nice cheers. All right.
So you should pass this around too.
While we're setting up the chairs, I am reminded that tonight the Fleet Science Center doesn't close until 8, and I was told that if anybody would like to go after the conclusion of our program out those doors, you get a chance to see the museum here for free. So it's one of the many perks coming to our program. So.
Okay, actually, the other day on Monday, Phil and I were on KPBS talking about this issue, and before we were introduced, they said, well, we'll call you Professor because then people will respect what you have to say. But I'm going to call everyone by first names because I don't buy into hierarchies. So if you have any specific questions for Cease or Phil, why you let us know who they are, but please ask questions.